So next we got Conrad Barski. Come on up here, Conrad. And Conrad Barski. Conrad Barski does it's cardiac software, right? Cardiology software during the day. As he mentioned, he runs a website for rare languages.
It's actually a
Fringe
local group
right.
in DC, but yeah, there is a website.
Excellent. Well, go ahead. Take the mic up here. You stop this. The screen keeps changing.
Sure. Great.
Do you want to bring that up here? Is that easier for you?
Oh, I think this will be fine.
Okay, you're good there.
Yeah. I'm going to be a little more primitive here, no PowerPoint even. As I was mentioning earlier, I run this little computer programming club, and I've always been thinking about the idea of somehow linking that with Dorkbot, so trying to somehow get a sort of an artistic element into what I do with that other group. And so I was thinking about different ideas, and what came out of that is this project called Picnic Mom. So here's basically how it would work. So I was sort of thinking, I think all the time sort of what computers are good at, and if you look at this day and age, now that we have computers and we have the internet, you know, what are the kinds of things that maybe people haven't looked at in the past that maybe would be interesting to explore now that we have these elements? You know, and so these are sort of, you know, the three sort of main things I can think of that really the internet and computers get you that we didn't have before. The first thing is that you can see things that were previously hidden, and this is sort of very obvious. Like if your neighborhood association has a newsletter, in the old days you'd never know about it, or if you happen to go to the meeting, maybe you'd get the newsletter or something. Now you can just type that group's name into a computer, and up comes their newsletter, right? And there's a million different ways, being able to look at your house with a satellite, and all these kinds of things where we can see all these things that were previously not available to us. The second thing that computers are good at is that you can just throw all this amazing computing power at human problems, and in some very limited domains, maybe you can actually do something useful with all that power. The typical example is Google. It just has these immensely large but very dumb algorithms, and they solve very useful problems for us. And then the third thing is, and this is sort of the area I think when people talk about Web 2.0, what they're kind of thinking about is this idea of creating new ways for humans to interact with each other. So I was sort of thinking about this and just trying to come up with some way maybe that nobody has looked at. And I remember like a long time ago when I was a little kid, maybe like 2 decades ago, going to Epcot, and where you go like into the little German pub, and then or the English pub, and the German Via Halle or whatever. And so you go around, and then you realize very quickly that it isn't really at all like the world. I mean, it would be nice as sort of a miniature version of the world. But you go around, and all the people that work there are just the people from Orlando that have a job there. And you really don't get that feeling that this is sort of a miniature version of the world. So I was thinking, well, how could you improve on that? Well, you could, in a way, you could take it even a step further, in that maybe the way communities really fit together don't necessarily fit together in the same way as our geography does. Wouldn't it be great if people that have similar interests could be sort of near each other or in the same neighborhood in some sort of virtual way? But what I thought would be really cool is if you could get everyone into an actual place to sort of create sort of a map of different types of people and what they're interested in. And of course, when I thought of that back then, there was really no way of doing that. But now that we have the internet and we have computers, I was thinking, okay, well, how can we sort of make that idea happen? So basically, the basic idea is you somehow want to take human interests, whatever they are, which is basically data on the internet in cyberspace. And somehow maybe we could translate some of this data that we have about what people are interested in into locational data in the real world, and set it up in a way where people who have similar interests would be near each other in the real world. And then maybe you could do something interesting in that way. And other people have, of course, also sort of worked with these kinds of ideas, like I'm sure you've all heard about the Libertarian Party. They were talking for a while that maybe they would declare Vermont as the official libertarian state, and everybody should just move to Vermont if they're libertarian, and then they could have their own little libertarian utopia in Vermont. So, and we also have, there's certain places where deaf people have come together and formed, like declared a certain town to be deaf-friendly, and then they would all go there, and then they could interact with people that they can communicate with better. But what I was interested in is just doing this more frivolously, kind of as an art project. And so why would you do it as a picnic? Well, what I want to be able to do is you need to get a lot of people all into one area somehow, and ideally there would be some sort of open space. And the other thing is the worry with any kind of project like this is nobody, if you set this up, knows if it's actually going to work. Maybe there's supposed to be 800 people coming or whatever, and then you're like the only guy showing up, and you look like a chump because you're standing there all by yourself or whatever. So the nice thing with a picnic is that it's parks are large open public spaces, and then it requires you to stay in a certain place for a while. So that works really well. So if we could somehow create a two-dimensional map of everybody's interests, then we could map that on top of a park, and then you could eat wherever you sit, and then you could wander around and see what the different people from the different communities are like. And of course, you could meet your neighbors while you're eating, and those would be people maybe with the same interests as you or similar interests. And then there's a low cost of failure. So I was thinking there would be less of a chump factor, because if what's the worst thing that could happen? Well, you end up having a picnic on a Sunday afternoon. That's not that horrible. And then I figure everybody likes picnics, and so that's sort of why I was thinking a picnic would be an interesting way of doing this. Okay, so what did I do? Well, I just put together a website, because I had no idea what the response to this would be. Maybe nobody would find this interesting. So I created picnicmob.org. Got the internet. Ask me later. Okay, so I created picnicmob.org. So, and basically what you have on here, this monitor is kind of small, so everything comes up first. So there's a bunch of questions on here. So you go to this website, and it'll ask you, if you could have a time machine that could peer into the past, what would you look at first? And then you have some things you can pick. So let's say Socrates, right? And so it's always a trade-off. How big do you do these things on the internet? You don't want to get too fancy with like different font sizes and stuff. And so, but there's just a bunch of silly questions. There's a total of 30 of them. And the idea was to just pick sort of frivolous, non-confrontational questions that cover sort of a large range of things. And the hope is that somehow, if people answer these questions, that even though they all seem frivolous, that somehow maybe some small smidgen of your personality or whatever would come through, and so that if somebody else is similar to you, maybe they would also have similarities in more serious areas, politics or whatever, or whatever you consider serious, that somehow magically, by just throwing a lot of dumb computer power at it, and organizing this picnic, it basically you would end up with these communities of people that have similar interests. So the basic idea is, so how does it work? Well, we ask questions of all the people. Then we take all the answers people gave and a map of a picnic in your area, and we put it into a computer program called this simulated annealing algorithm, which is what I'm going to show next. And it basically tries to figure out the perfect placement of everybody so that their neighbors are as similar to them as possible. Then once enough people have signed up, and I list there as a number of 1,000, which I thought would be like a totally ludicrous number, but I'm actually getting a fairly decent response, so we'll see. And then, like the day before the picnic, you would get an email, and it would have a map, and it would say, you should sit right here at the picnic, and then it would also give you statistics of, what the people around you are like, and then maybe some kind of maps where it looks for emergent areas. Like I would assume that certain questions would end up becoming trigger questions where a lot of people that answered, A on question 5 or whatever, are all in the left corner of the park. And I haven't actually looked at that particular part. That I haven't done that kind of analysis so far. So this is basically the idea. Let's see here. So I just put this up in late July, and so far I've gotten 2,500 hits, signups. So I don't know how many hits, probably like 80,000 or something like that. So and so it's gotten on. It hasn't made the A tier of websites. I'm not like at the top of Reddit or Big or anything like that. But I made some smaller things like Metafilter and what's it called, Gothamist, and a few other sort of similar sized venues. So I get I'm getting a decent number of hits, and so the largest areas for people who signed up is about 1,000 people in the New York area, and actually a fair number of people in DC have signed up because I sort of started it here, and probably some people may know who I am. So we have 650 in the DC area. Now the problem with this is of course people may just, some guy may be in Germany and just randomly playing around on the net and saying, yeah, let's see what happens if I go all the way through this, and then that's not really a real sign up. So I have no idea right now how many are in that category. But my goal is, I'm hoping I can get about 1,000 people in a particular city that at least have signed up on the internet, saying that they would come to this, and I'll be happy if 100 people show up. But you never know with these things how it might work out. So let me talk a little bit. So as you can see, this website is extremely primitive. It's programmed in Ruby on Rails, but all it basically does is go through a bunch of questions, and then it does use Ajax to go through the questions, and then just stores it off in the database, sends around a couple of emails. But I need to really beef this up in order to really get more people to sign up. So that's currently what I'm working on. And of course, once I had this working, the next thing was, well, how do I actually do all this map? I was pretty confident it wouldn't be too difficult, and it wasn't too bad. Let me show that. So I'm actually, because I like obscure programming languages, I wrote this in a language called Haskell. So the interesting thing about Haskell is that Haskell is the programming language that's the most like math. So when you think about like programming languages, if you've ever programmed in a programming language, and you think about, well, how does this programming language differ from math? The first thing that comes into mind is, well, you have functions in math like sine and cosine and stuff, but how would you like print your name on the screen in math? There's nothing like that, right? And that's basically what Haskell is. What they did with Haskell is they basically broke programming into two parts. Those parts that are exactly like math, and then everything else which has to do with like writing the files and putting it to the screen and actually making that work. So it's like sort of two mini languages, and making that work is actually very a complicated problem. So most of this is written in a form that basically is like math. So I'll go, since there's a fair number of programmers, I'll kind of walk through this real quick. It's kind of interesting. So I'm actually going to turn this into a little Haskell tutorial. What's nice about it is that I use SVG graphics, which is a simple graphics file format that's becoming popular now. And so you can actually draw the map in a drawing program, Inkscape, and then this program will take that file and then it'll output intermediate steps as SVG files. So it makes a great tutorial because at every step you can actually output a picture to see what's happening. So here I just declare all my different types. You know, a point is 2 floats, a color has 3 integers, and a polygon is a list of points. So you know, it makes sense. So for people who are like into Ruby and stuff, the thing with those languages is that those are dynamically typed languages. And a lot of people think that that's kind of the future. Well, Haskell is the exact opposite, static typing, but we want to be as absolutely extreme about it as possible. And if you make it as extreme as possible, all of a sudden some of the ugliness of the static typing goes away. So yeah, that's what. But basically, you'll see a lot of types in Haskell. So first, I just so this is the Hello World program. I declare a few types up here, but this is pretty much the Hello World right here. So if you were to run that, all that program would do is print Hello World. Okay, so here's my data files. These are some answers people gave to questions. So one person answered 1, 3, 4, 2 on the consecutive questions. And so here's the program that would read that in. So you can see it reads a file in here. So this, since it reads from a file, as I said, this uses the other language. But then everything else is basically like math, where we just say, you know, so people are just equal to, and then there's a function that gets applied to the text of people, that kind of stuff. And then, so this would then just print out the number of people. And then, of course, what we want to do is we want to be able to draw graphics. So here's something that will write an SVG file of polygons. So here's the code for that. So after I do this, my pictures.
Your next door is helping me find out this
Oh, there's some crazy security thing.
Yeah.
Lock. Yeah, it's.
Oh, there.
Well, this is Internet Explorer. You have Firefox, by any chance? I forget. Internet Explorer doesn't natively support SVG files. Forgot about that. There's a reader you can download, which actually is annoying because I would have wanted to do the whole website in SVG, but Internet Explorer is the plugin for that. How am I doing on time, by the way? Just sort of a layer, just in case.
Do something.
Okay, so here you can see this is the code that would write out some squares. So I just write polygons and I want to write it in blue. And so I'm not using any libraries, it's just using the actual code from above. So the code for that is just this. So this basically lets you write SVG files. So it's a very compact language. And here's a picture of this is Stanton Park in the Northeast Washington DC. And so here's the code for reading in that data. So this will read it in polygons. So you can see I'm doing regular expression calculations here to read that in. And then here it is inside my program. And then here's the algorithm I use. So this is a pretty simple algorithm. First of all, I triangulate all the polygons of the park. Then what I want to do is I want to be able to slice the park into little lots for each person. So I know how many people there are. So I have a function, and that was the code for it, that basically can slice the park along horizontal and vertical axes. And then what we do is by doing that, by taking all of our people and breaking it into a lot for every person, we end up with this. So this basically, so all of these lots are equal in area, or very close to it, and it uses some heuristics to break it into equal sized lots. And then we go past that. So here you can see these are all the people. And then what we can do is we can create a network based on distance. So what I've done here is these are who I consider to be your neighbors on this map. Now we're going to use a simulated annealing algorithm, which means these people are basically going to act like little atomic particles. They're going to run around the park, and depending on how happy they are or how unhappy they are with their neighbors, that will determine the amount of energy in the park. And so we can run a physics simulation to bring the energy to be as low as possible, which means everyone is as happy as possible. Now the problem with this, I call this the sitting neighbors. So these are your neighbors from a sitting position. And the reason I do that is because there's an island in here that is not reachable from the outside. So I have a second algorithm that calculates walking neighbors, which guarantees some connections to this middle area. So basically, this determines where... Oh, yes. Oh, yeah, sorry. So basically, what this allows is that this is basically where people, it's like everyone just walks around the park, and these are the paths they're allowed to use. And then the happiness of each person gets determined by that other map you saw, which are basically a more limited subset of neighborhood. And then basically we can now mark this park based on how similar they are. So what I did is I took a bunch of raw data from my program, and I basically just randomly threw these people into this park. And you can see the lines tell you how similar they are to their neighbors. So blue means they're similar. They have a lot of similar interests. Red means they're dissimilar. And I used for this just a simple count of how many questions they disagreed on. And then what we want to do is do a simulated annealing algorithm. And you can read about this right in the Wikipedia article in simulated annealing. And basically what you need is you need 4 functions. You need an energy function, which tells you for a given park configuration how much energy is there in that park configuration. Then you need a function that can move 2 people so that they swap places, which is the motion function. And these are just almost like functions in math. You can see what it's saying here is in order to determine the energy, we need a list of the various links in the park, and then this function will then use the number of mismatches and basically calculate what the total energy is by summing the number of mismatches. So so basically you stick data in, it pops data out. So there's no arrays or any sort of state variables or anything like that. Then the next one is you need a temperature function. So basically what we want to do is start with a really high temperature so everyone runs around quickly, and then we want to slowly cool it down. And our hope is that as we slowly cool it down, people will crystallize exactly in an optimal configuration. And then the last thing is a transition probability function, which determines, based on the amount of temperature and based on the delta of the energy, what's the likelihood that 2 people will swap places. Now, okay, so then we can run this. That tells us the starting energy and stuff. And then here's the actual annealing function. So I could go through this. This is taken right out of the Wikipedia article. It just uses those other functions we've mentioned. And then here's the actual loop. Now there's no loops in Haskell because loops would imply that there's a local variable, which you're not allowed to have. That local variable that changes value. You know, it goes 1, 2, 3, 4. What you have to do is you have to use something called a fold. And this was actually the nice thing about Haskell is it's so strongly typed that it's actually difficult to write a program with a bug if you can get it to compile. But it's a hell to compile. So, and rarely, I mean, I spent maybe 5% of my time on this debugging once I had it to compile. And the one bug was right here. This was supposed to be a fold L. So this is actually a bug in here. It takes that fold R. Which means a left-handed fold instead of a right-handed fold. Anyway, so then we run through this, and now, as you may be able to tell, it's more blue than it was before. So here it is now, and here's how it was after before. And of course, these colors are arbitrary, but the bottom line is they're a better configuration. So this program here is designed for teaching Haskell. So I have another version of this. This one uses mainly lists to do all of its work. I have another version that uses more optimal techniques, and it's about 1,000 times faster than this version. So this version can do, I think, like 10,000 movements per minute or something, and the one I have that's optimized can do about 10 million per minute. Anyway, so this is working out, and so basically the idea is that every night I'm going to run this for each park in each city. So there's a total of 5 cities, DC, New York, Chicago, San Fran, and Boston. So I have a park in each one of those. I run this algorithm, and then overnight I would recalculate the new optimal placement for everybody. Now I'm working on the front end for this. So the idea being that what you don't get right now, once you go through the whole process at this point, all you get is a remind me here. This is not loading. Okay. There we go. So what I need to do is get to the point where people get a reward when they go to my page. So once they go through all the questions, they want to see something. They want to see some kind of cool graphics of a park where they can click on things and see who their neighbors are going to be and that kind of stuff. So that's sort of the weak part right now, is that I need to do all of that JavaScript-y kind of programming to make it happen. And this lends itself to some interesting visualization techniques in that, so basically we have a total of 30 questions, right? So we could make a little bitmap of 30 pixels, which is a 5x6 grid. And then you could quickly scan the park. So this is actually a little small for the screen, a little large for the screen, but this is one corner of Lincoln Park. So this is now the new location where this is going to be. So you can kind of see how similar people are when you get up close by seeing the similarities in pixels. And then you can click on things, and then it'll show you, that's what this person answered. Then you'd be able to click on one of these boxes, and then it's going to pop up a window saying, on this question, this person answered this, and this is what you answered. But I need to do a lot more for this. There's going to be it's going to eventually, hopefully, look something like this, where we have some kind of so you have an actual satellite picture, which is of course easy to get these days. It'll show you where you are. It'll show you where sort of all the different people with specific interests are, and I need to somehow calculate by doing cluster analysis this kind of information. And then I want to have these kinds of maps that tell you, for interesting questions, where do people that answered certain things on certain questions sit? If there's some interesting patterns there, put that in there as well. So I'm working on all of this now. So the goal right now is to have the first. Now, so far this has been pretty successful. I've got a fair number of people signed up, but of course this can only be so successful until there's an actual picnic. The goal right now is to do these as early as possible in the spring. So March 23rd will be right around the start of spring. So I'm hoping to have a picnic in DC on that date, and then a week later in New York, I'm going to focus on those 2 spots. So what I'm trying to do with this is I want to do this completely non-commercial or anything. It's just purely a fun art project. And there's one tricky thing though, which is that a lot of cities require some sort of permitting process for parks. I'm currently working with the Eastern Market Foundation. I'm sure you guys all know the Eastern Market building burned down, and we have a foundation to pay for that. So they're willing to help me to get a permit, because for DC, if you are a charity, you can get a permit easily. So the goal is, what I want to do with this in general, is turn it into some sort of conduit for charities. So the idea is what I want to do is get people, instead of going on the internet, meet people locally in their town or whatever, and then also have local charities that are tied in with it. So it's sort of make it in a kind of a local arm of the internet in some small, obscure way. And so the idea would be to have charities that sell picnic lunches, and they would get some revenue from that, and then you could pick that up and eat it at the picnic. And so that's currently where I'm at, and now I just need to get the website to be nice and solid and get as much publicity as I can so that the first couple of picnics are a success. So, any questions?
Once I arrive at the park, how do I know where to go?
Well, you would have a map like this.
I would have printed a map already. And
yeah, you would receive an email a couple of days earlier with this map, and it would have all this information. It would have an arrow showing you that's where you should sit.
I think you're going to need more than a couple of days to notify people about where they need to go.
Yeah, well, so
administratively, there are a couple of one of the other things is, contract when you check the IP address of the people who are sending you these requests, there's at least some kind of match to where they are.
I hadn't thought of that. That's a good point. That would be a quick, easy way to check how legitimate these sites actually are. How to do that.
Seems to me,
Go to the front one.
seems to me a better proposal filter than that, or two-top filter, is to require people to pay some amount to your charity online. They should be serious, because I could be in Chicago, but it could be in DC, that would be legit. My IP address could show up as this area.
Well, I mean, it's always tricky because once you do those kinds of things, you're always going to lower the amount of people that are willing to go through that
That's
headache.
true, but if you get a substantial number of people to sign up and show up, I could be sitting in the middle of the field waiting here's the
Right. So I'm trying to work that out right now.
I think that charity connection you're talking about mitigates some of that because then you have a local connection.
Right. I mean, if I mention the Eastern Market Foundation with this in DC, most people will think it's legit.
Instead of taking the whole area of the park and dividing it by the number of people that you have, maybe you should take a constant area per person and then fill up as much of the park as you have people show up. Because with that sort of thing, you could have people that are, even if everyone shows up, pretty widely spaced apart filling the whole park. It might be better to just fill a corner of the park, but have one blanket size per person or something like that.
Yeah. Well. Yeah. I mean, would you suggest how would people find out about it? Because that would need to be kind of dynamic. As people show up, you would know how many people there are.
Well, I mean, you're accumulating your database. You know how many people there are, and then that number of people times 8 square feet or something is the area.
Well, yeah, I am planning on having some official size for a picnic area. And right now, I'm assuming that I don't have a very sophisticated RSVP process, which I don't want to get too sophisticated because I don't want people to not show up just because they forgot to RSVP. I don't want to make it too complicated. So right now, I'm thinking, along the lines of like 2 feet by 2 feet as a picnic area, which of course is too small. But I'm assuming that 80% of people aren't going to show up. So I don't know. It's all a delicate balancing act. It's good.
It's really cool that you're using sort of a dynamic algorithm to figure out where people are, but then assume that they're going to staff. My concept of what I would do in a situation like this is I would go to my place, and then I look around, and then I start moving.
Yeah,
That's like
just
a simulation. I would start moving around. I think maybe that's the interesting part is you have a number of people show up, and you make a system where you'll actually dynamically configure itself right there. For example, what you could do is you could pick out a badge which has some sort of a more shape and color with a more similar to shape and more similar to color. You have the more likely you are to be neighbors with someone who has a similar looking, little ID. So instead of name tag, it's a badges that are
which is
a little more shape.
Geocaching.
It's something that will move around. And the cool
Yeah.
you can have like a video camera sort of like capture like how people actually move in the real space. There's similar morphs that people have seen in any
Right.
moving around.
Yeah, it would be great to come up with a way of doing this dynamic. Like, let's say everybody has a cell phone that is web capable. You could do something crazy where where it figures out right then and there in the park where everyone should sit.
No, people do it by themselves because they move, just like your situation.
Right.
Move around random. It's perfect. They already do exactly what you're saying.
Right, but they can do that at a party. They don't need to come to this event.
Well, the point is that, then they try to localize their similar ones that they'll self-organize, just like you want, I think.
Right, well, I'll have to think about that. I would love to do this dynamically somehow.
Well, if you did something with the whole RSVP lot, where 5 days before, you tell them, okay, RSVP.
I'm definitely doing that.
And
have a
at
single
that
email
point,
like that.
you can now narrow down your set, and maybe even have an RSVP point at the center of the park. Where you can say, okay, here's where you should go. But by having the RSVP, you can do a last-minute simulation with those, and then also do a broader simulation, so if people show up unannounced, you still know the general area where to put them.
Right, I'm definitely doing that. Basically what you described. The thing that I'm worried about is that even if people RSVP to some email, they're still not going to show up. That's what I'm worried about. So I need like a double RSVP. So in theory, paying to a charity would accomplish that.
Maybe pay $5 for the bank.
Right, but I don't want to like turn this into something where people feel like they're being leached for money. That's not fun either.
They did something very similar to this in the late 90s in the Media Lab with the MIT. And what they did was they gave out tags in which the visitor at the MIT lab booked to a station and answer about a dozen questions. They programmed that tag, and then they wore it with a little LED on it. And the closer you were to somebody who shared your interests, the LED bars would go up. So you'd wander around, you got to somebody who shared some interests, you'd see their badge go point, and they'd see your badge do the same thing.
Yeah, I've heard of Japanese toys that work similar to that for like dating, meeting good matches in the subway and stuff.
Keep dating, I guess.
Yeah.
The world, man.
On the RSVP pitch, is there a way you can maybe make people feel committed without actually having them commit any further by like making the same potluck picnic and asking them, are you coming and what are you bringing? And then like if everyone in an area, you can see what similar people are bringing. Not only do you have an incentive to trade with them, but then you also feel an obligation because you said you would bring the drinks and like who's going to bring ISD if you don't.
That's a really good idea. I hadn't thought of that. Now, that adds another sort of layer of complexity, so I may want to keep that into like version 2. But I can see how that would work. It would be an interesting way to incentivize people.
Well, one thing I remember, when I registered for Gmail, one thing that they did is they used SMS as a way to communicate back with you to sort of make sure you're real. And I wonder if you get that way, you could get a phone number, and then you give them a code that they put in to verify. But with that, you could also see generally what their phone, what their area code is. So that might be a way of finding out whether they're actually there.
And you can put people dynamically with Twitter. That's what Twitter is their favorite around.
We were kind of on the same tip, because I think it's hard to get the charity to sell the picnic to people, because then they're out and they not know how many people are coming for lunch. But I was thinking you could get restaurants near your park for free, and people bought lunch at those restaurants, they give $1 or $2 of the lunch price to the market.
Well, that's what I'm working. That's why I'm working with the Eastern Market on it, because that's why I'm moving it to Lincoln Park from Stanton Park. Because that's right, it's walking distance from the Eastern Market. And I figure that even if I can't give people good numbers in terms of how many people are going to come for lunch, there's probably enough elasticity in the Eastern Market to be that if there were a few vendors that have some special picnic lunch, that they wouldn't care if 10 people buy one or 500 people buy one.
And in turn, you can email the list of people in advance, so they know that are
Right.
I worked on a project that didn't have anything to do with picnics, but that had a similar problem. And knowing how long it took my terrible Perl script to run, I'm wondering how quickly your routine can figure out these problems. You said it's like a vector like 30 for each participant and probably a few hundred people, or no, 1,000 people per part.
Yeah. Well, as I said, it does. I think I can. If I run it for about an hour or so, it switches. It can do 10 million people switching. Now, my current data set is only 300 people, so I don't know how many people will RSVP. It's probably a realistic number. So, and then it seems to. I have some graphs. I don't have the data readily available. basically the longer you run it, the payoff for running it any longer starts diminishing. So you can get pretty good results. I can get pretty decent results in like an hour of running the program. And of course, I can't do that with my ISP that's running my website because they if you run a website at some company, and you might have a PHP script that does some calculations, but if it runs too long, they have special process watchers that will kill anything because they figure it's probably crashed and it's been running. I've just been taking too many CPU cycles. So I'm running this actually on my desktop, and I'm going to have sort of a cron thing going on, where every night it gets the latest data from the server and then runs on my home box all night long, trying to arrange people and then sends it back. So.
Unfortunately, I think we don't have time for. Is there one more question up here? Yeah, let's just take one more question.
I visited the website and I was answering the questions, and I noticed that a major assumption is there's only going to be one person attending. I was wondering if you took into account couples, because you don't want to drag your significant other and have them be with people that are boring to him or her.
Well, that was a question I kind of struggled with because I didn't want to make this like complicated. I didn't want to have like some flow chart where you decide how you should answer the questions. So I just said at the bottom of the website, I say if you're a couple, answer the questions together, or answer them separately, and then you'll sit at different places. So one last thing, I think it would be really interesting. One of the major criticisms to this idea has been that do we really need to meet more people just like us? Maybe we should meet people that are different from us. Maybe that would be better. So it would be interesting to do a picnic like this in the future, where where I basically flip the switch, and you end up sitting with exactly those people that are least like you, and seeing what that would be like as another experiment.
You just maximize the energy.
Yeah, we can get out there. I just have to flip the switch.
Okay, well, thanks a lot, Conrad. That was very interesting. One of